Yeah, let's click it.
Okay. All right, so hi again. I'm Chris Norden, I'm a senior staff developer support engineer at Sony Computer Entertainment. I'm going to be talking today briefly about just kind of the system in general, kind of give you a quick overview, some quick tech specs. Feel free to ask questions at the end. This is not really a very technical day. This is more of a design and idea focused day. So we're not going to go really deep into the core of the chips or the architecture or anything. That's going to come later on this year at a more technical conference. But feel free to ask any questions. If we can answer them, we'll answer them. If not, then we'll say, sorry, we can't answer that. So what is the NGP? Well, everybody should know that by now if you're here. We'll basically take the strengths of the PSP, which is all the cool buttons and interfaces, the beautiful large screen, and we're going to add some new input options. We're also going to address some of the weaknesses that the PSP had, which was poor connectivity. Media wasn't everybody's favorite. We're going to make it a lot easier for developers to develop for and a lot cooler as a device for you as a consumer to own. So it's definitely going to be more connected. We have Wi-Fi, Bluetooth. It's going to be kind of more persistent. There's going to be a lot more going on with the device. It's going to be a more kind of social connected device, to use the whole social buzzword that everybody's using these days. And we're going to fix the piracy issues that kind of plagued PSP. PSP was hacked like minutes after it was released. So we're going to definitely take care of that. It really is going to be, I don't think not just a platform, but the platform for AAA quality handheld gaming. So you guys have seen it by now. You've seen the final form factor up there. It's what Japan refers to as the super oval design. They like buzzwords and clever design terms. It's just a little bit bigger than the original PSP-1, which some people call the PSP Fat. So physical size, when you pick it up, and if you had an original PSP-1 right next to it, it's pretty close. There's a few millimeter differences in a couple of dimensions. It actually feels a little lighter than the PSP-1. I don't remember the actual weight specs and everything, but it feels lighter to me. Again, these devices don't have final batteries in them, so they're not going to be exactly representative, but they are really, really, really close. PSP screen was only 4.3 inches. The NGP screen is a full 5 inches. It is massive. It is gorgeous when you're holding it in your hand and looking at it. It is really, really big. It's OLED, incredible contrast, black levels, brightness. It's amazing. It looks fine in bright sunlight, looks great in the dark. It's the best screen we've seen, really. It's pretty impressive. And it's what we call a candy bar format. So that just means it's not a slider like the PSP Go. It's not a flip like a Motorola StarTAC phone. It's just a single slab, and everything is right there. Screen, yeah, it's huge. It's awesome. It's gorgeous. You can't really do it justice in pictures. You have to sit there and hold it and play with it. So everybody, be sure you get a chance to get it hands-on today and play with it. 5-inch OLED, gorgeous color reproduction. Everything is amazing. Again, resolution is 4 times the resolution of PSP. PSP was a 480 by 272. This one is 960 by 544. So it's exactly 2x in each dimension, which gives you 4 times the number of pixels. Input devices. Same as the PSP with the addition of a second analog stick that everybody in the world has been yelling for ages. So D-pad, face buttons, left and right analog sticks, and left and right triggers. Now note that all the buttons are digital. Unlike on the PS3 DualShock, where the face buttons and the triggers are all analog, it's all digital, just like on the PSP, except of course for analog sticks. Those are obviously analog. It also has 6 axes of motion sensing. So there's a 3-axis accelerometer, just like in a 6-axis. It also has a 3-axis gyroscope. The 6-axis controller actually only had a 1-axis gyroscope, which was around the yaw, or the vertical axis sticking up through the controller. So this has a full 3-axis gyro. Touchpads, yep, we've talked about that. That is one of the really cool things that nobody else has, is a rear touchpad in addition to front touch. So you can do some pretty cool things with pinching, zooming. There's cool gestures you can do. We actually provide a full system library for simple gesture recognition for the UI and everything. And then you'll see some cool demos later on by AI Live with some neat gesture stuff. Very high resolution touch panels. Like I said earlier, it's the current resolution is 1920 by 1080, so you get sub-pixel resolution from the screens. So you can get really, really precise touches, up to 6 simultaneous touch points per panel, that's front and back. So you get 6 on the front, 6 on the back. You also get a force or pressure feedback, which Dave's actually going to talk a little bit more about later on in his specific touch presentations. But note that it's not physical pressure, it's actually surface area. So when you push down on it, it squishes your finger more and you get more area. So there's some caveats there, but Dave will talk about that. Cameras, more input. We got a front camera and a rear camera. They're extremely high sensitivity, extremely high frame rate, 60 frames a second. They're intended for gameplay purposes. You're not going to be going out and taking awesome digital photos with them because they're VGA resolution. That may sound like really low res, but for AR games and some of the gameplay type stuff, it seems to be just fine. We've done a bunch of tests. There are some limitations and there's some stuff you have to be aware of, but Dave will talk about that more when he talks about cameras this afternoon. So, storage and distribution. We're using a proprietary game card format. It's a flash-based format. It's not SD, it's not any of these other formats. It's completely proprietary, but it's very similar to any flash-based formats that you've seen. Sizes currently are 2 gig or 4 gig, minus a few percent for an area on the card reserved for save data, patches, possibly DLC, whatever. It's really up to the publisher, and we may, I don't know if we're going to talk about that more in detail today or not. Probably not, but that's something you can talk to your account manager about. And the game card actually contains some writable memory area as well. It's mostly read-only, but there is going to be some writable part of it for this data that we're going to be writing to it. There's also a removable memory slot, which again is a proprietary format. The cards will be pretty large. Obviously, you guys know kind of what the trends are with SD, HC, and SDXC cards right now, where the sizes are going. This is the primary media storage for the device. There's no flash memory in the device. It's all going to be on the removable card. And it's going to be quite a bit because that's where you're going to be saving DLC, you're going to be saving downloaded games, you're going to be saving your personal information. If you want to put photos, music, movies, whatever you want, that's where everything's going to be. And there is going to be a single submission for both formats. So you don't have to resubmit for downloadable versus card. It's just a single submission, same package, everything's just going to work. So it should be a lot nicer. Connectivity, we're going to have 2 SKUs. One is going to be Wi-Fi only, one is going to be Wi-Fi plus 3G. The 3G models will also have a GPS unit built in. Now, you may be thinking, oh, well, Wi-Fi people are still going to want location-based services. Well, you still get that because there's the Skyhook positioning service that we're going to use for the Wi-Fi stuff. And it does that by, there's like this massive Wi-Fi hotspot database that people like Google contribute to when they drive around and do their scanning. And it can kind of give you a rough location, not super accurate as GPS, but pretty rough location within, it's probably less than 100 meters or so, depending on how many hotspots there are in the area. So even if you don't have the 3G model, you can still get some pretty decent positioning info, which we will talk about later on as well, because there's some really cool stuff we're doing with location-aware apps and position data. Hardware, here's a quick overview of the unit. I'm going to throw a bunch of numbers and letters at you. Feel free to go to sleep, but I'm going to throw them out anyway. So the system on a chip is actually everything. It has the CPU, the GPU, RAM, interfaces. It's pretty much the entire device is a single chip. It's really, really cool. It's super dense. It's super awesome. It's super power efficient. The core of that chip is the ARM9. It's the ARM Cortex-A9. It's actually an ARM v7 architecture. It's a quad-core processor. Of those cores, you get to use 3 of them. One core is reserved exclusively for the system, the OS, all the system services, everything. So on the PS3, when you were writing code, the system would interrupt you every once in a while to do things like audio processing and other stuff. That's not going to be the case on NGP. You have 3 full cores all to yourself, so you don't have to worry about the system messing with you. The graphics processor is a Imagination Technologies SGX 543 MP4 Plus. Now what that means is Imagination Technologies is the company that used to make the Power VR chips and the Dreamcast. They make almost every mobile GPU out there these days. Pretty much any phone you pick up is going to have an Imagination Technologies GPU in it. They're very good at very small devices with extremely low power consumption and very good graphics power. Now 543 is the family. MP4 means it's quad core. Plus means Sony has added some very specific features to it that nobody else gets. So we've added special texture formats, frame buffer formats, debugging hardware, all this other cool stuff that game developers really need that is exclusive to our chip that no one else can have. So we're letting you write really low-level graphics stuff that nobody else does. On phones, you can't do that. You get to use basically OpenGL, you get to use proprietary APIs, and you're going to lose a lot of performance that you're not going to lose on our platform because you're writing pretty much directly to the hardware. The system is going to have half a gig of RAM. Now this is main memory. Now you don't get all that for games. Right now you get half of that. You get about 256 megs. That may change in the future. It will not go down. It will only go up. And the reason we take so much memory is, again, The same reason we're taking a whole core to ourselves. We don't want you to have to fight for resources. Like on the PS3, we take quite a bit of main memory away from you, and you really only get about 192, 200 megs-ish to work with. We want you to have as much memory as possible. So we're taking about half of that right now for all the system stuff. Because remember, it's a game machine primarily, but there's also a lot of other stuff happening in the background. A lot of location stuff, a lot of things for notifications. There'll be apps running in the background. There'll be stuff going on that won't interfere with your game, and your game will always have front priority. But while you're playing a game, if a friend wants to chat you or send you an invite or something, that's going to happen, and that'll happen on the other core with the other memory, so you don't have to worry about it. There's also 128 megs of VRAM, or CD-RAM, you might hear it called. It's basically the video memory. Some of that is going to be used by the system. I believe right now it's about 16 megs, and then you also have to allocate other buffers for your rendering. So it sounds like a lot, but it's not tons and tons and tons. And there's also dedicated hardware on the chip for media playback, codecs, video, audio, all that stuff, so you don't have to do that stuff in software. Development kits. They are completely self-contained. They're going to look pretty much like that. PSP kits, if you'll remember, it was actually like a little mini tower with a tether and a screen on it. PS3 kits, I'm sure you've seen, you either have the giant 2U rack mount device that weighs 1,000,000 pounds, or you have the regular retail kit. Well, all the dev kits for this thing are just going to look pretty much like that. They're small, they're going to plug in with USB, they're going to be simple, silent, there's no fans, there's no giant power draw or anything. It just fits nicely on your desktop, and it's super easy to work with. The development tools are also a lot more mature than the previous platforms. We've been working really closely with SN, and we've learned a lot from previous platforms and mistakes that we made with the tools. So everything is fully integrated to Visual Studio now. So the debugger, the performance tools, compiler, linker, everything is all just built into Visual Studio. You don't have to have separate programs. So you edit your code, you hit F7, you build and run, you hit F5, it all just works inside of Visual Studio. No crazy interfaces, no anything like that. The Target Manager is now actually just part of Windows Shell. It's a Shell Explorer extension. So you bring up an Explorer window, kind of like another platform has its neighborhood. We now have NGP neighborhood. So you bring it up, and you see all your targets listed. You also see targets of everybody else in your studio. So the target is connected to the PC via USB, but the neighborhood is also communicating over the network to everybody else. So you can do bulk flash operations, bulk self-launches, data copies, whatever you want. So you could have 10, 20, 100 dev kits in your view and do whatever you want no matter where they are in the building. So even though it's USB connectivity, it's still networked, which is very cool. Platform support tools. Obviously, we're going to have broad support for the middleware industry. We have a couple of those guys here today who we'll talk to a little bit later. If you want to ask specific middleware questions later on, you can talk to Mike Richardson. He's back there by the TV. He's waving. If you guys need a particular middleware for your product, let us know, because chances are they're already working on the platform. We haven't done a full public disclosure of all that stuff yet, but we can hook you up one-to-one, and then you guys can start talking to them if you need a particular engine or tool or whatever. Also, scan the QR code if you want a quick link to our TNM stuff. Okay, done. Platform comparison. So talk really briefly about how NGP kind of compares to our other platforms, PSP and PS3, on a technical and kind of interface level. So here's the pretty little screen diagram that all the websites like to do when they're showing off sizes and all that. So PSP was 480 by 272, pretty small, but it was still a nice screen and it worked well at the time. PS3, well, you can do 1280 by 720, or you can do 1920 by 1080 full 1080p. Most people do 720p. NGP is kind of in between that, but leaning more towards the PS3 side. So it's 960 by 544. So it's not quite a full 720p buffer, but it's a lot more pixels than the PSP. And the screen is 5 inches. The resolution is 960 by 544. You can do the math and come up with a DPI. It's actually a very high dots per inch. You can't really see the pixels on the screen. It also supports MSAA. So if you MSAA at 4x, you really can't see the pixels. I mean, they just blur together, and you can sit there and look as close as you can, but you're not going to see the pixels. It looks really good. It's extremely sharp. It just looks fantastic. So feel free to get out your magnifying glass and look at the screens, but you're not really going to see much. So storage comparison. NGP storage is in between PS3 and PSP, but it leans more towards the PSP side just because it is a portable platform. And things kind of get expensive when you start adding a lot of flash. So most PS3 games are dual layer, well, They're close to a dual-layer DVD size because certain other platforms are limited by that. So you're around 9 gigs or so. We obviously support Blu-ray, which is up to 50 gigs for dual-layer, 25 gigs for single-layer, and there are some games that actually do use a lot of that disc, some of the bigger AAA titles. NGP carts are going to be either 2 or 4 gigs at launch, and you can kind of see a quick little graph here. PSP single layer was about 800 to 900 megs. Dual layer was getting up close to the 2 gigs. Small and large game cards are listed there, and then PS3 is, of course, pretty far off. Just as a point of reference, certain phone manufacturers limit their download size over the air to 10 megs. 10 megs is 1% of 1 gigabyte, and we support up to 4 gigs. So you can kind of see we want pretty high quality games. There's going to be lots of room for your assets. There's going to be lots of room for your titles. So you don't have to make a little watered down, tiny little casual game, although we do support very small game sizes. So if you want to do a small downloadable title, feel free. I mean, it's definitely that type of device where we want you to have it with you all the time. You can jump in and out, play games, look at messages, listen to your music, whatever. So small games work perfectly fine, but we also want to have that big AAA awesome experience. System architecture comparison real quick. PSP was obviously a single core, single processor, single hardware thread. It was very, very simple model, had extremely limited amounts of RAM. There wasn't super crazy stuff you could do with it, although people did some pretty amazing titles with it near the end of its, or near the latter part of its life. I don't want to say the end word, because it's not over. PS3 used the Cell processor, which is obviously joined by IBM, Toshiba, and Sony. It had a PPU and SPUs. These were asymmetric cores. So the PPU was a single core but allowed 2 hardware threads and was the full processor. The SPUs were actually very special purpose, extremely high performance and bandwidth cores that were completely different from the PPU. So it was a different programming model. It was a little tricky to get a hold of. It took some time before developers really understood. You can crank through a lot of numbers on the SPUs. They are insanely powerful, still more powerful than anything else out there in the consumer space, really, when used properly. But it was a little tricky to program. The program model was different. NGP, we're using 4 completely symmetrical cores. So all the cores are identical. There's no special programming model. Again, like I said earlier, you only get 3 of them because we reserve 1 for the system. But it's extremely similar to certain other unnamed consoles and general purpose PCs. So the programming model is really easy. You're very familiar with it. It's an ARM processor, so you don't have goofy things like load hit stores like you had on a PowerPC. It's just a much easier architecture to program. So your development time and ramp-up time should be significantly faster, which is good for everybody. Main memory comparison, here's another pretty little graph. NGP has a lot of memory compared to PSP. I think PSP had like 24 megs that you could actually use of main RAM, just not very much. I mean, that's like the size of some people's textures on their games. So 256 megs are fully usable by the apps. That may actually go up. We don't know yet. The SDK team is still working on the OS and everything. So there's a chance you'll actually get a little bit more than 256 megs, which would be pretty cool. OS and other system services have their own reserve memory. They will never encroach on yours and never touch it. Ironically, well, not ironically, but interestingly, you have more main memory than you had on the PS3 to use on this tiny little portable device. So that should give you an indication of how powerful it is. Graphics, PSP used a fixed function graphics pipeline. It was kind of like OpenGL 1.2. It had some really cool stuff you could do in hardware. It had some hardware tessellation and curved surface calculation and automatic morph targets and stuff like that. So there were some neat things you could do with it. Not many people took advantage of it, unfortunately. But no shaders. PS3 and NGP both use programmable shaders. So it's shader model 3-ish. There's some features from other things, but it's roughly shader model 3. It uses the CG language just like PS3, so a lot of your shaders will come straight over. You may have to reduce the pass counts and the complexity a bit, but they'll come straight over super easily. Video RAM. NGP has 128 megs of VRAM. Some of that's taken by the system and your own internal render buffers. There's actually a lot of different types of buffers you have to allocate on the Imagination Technologies architecture. It's a deferred rendering, tile-based deferred rendering architecture, which is different from traditional rendering. It requires some different types of buffers, so all the tech people out there will no doubt be familiar with that, but it is different than what you're used to. Textures and vertex data can be in main RAM if you want, just like on the other systems. They don't have to be in VRAM. You'll get better throughput if they are in VRAM because there's a higher speed bus which connects the GPU to the VRAM. Yes, there is actually a little pixel there on the PSP video RAM. I think it had 4 megs of VRAM. And of course, your render targets had to be in there. So realistically, once you allocated render buffers and everything, you were left with a few hundred K. It was kind of rough. So clock speeds. Oh wait, I'm not going to talk about that yet. We haven't finalized it. Don't ask me what the clock speeds are. Don't post on the forums asking what the clock speeds are, because you're going to get the same answer every time. Sorry, we're not available. We can't talk about that right now. So they will be finalized this year, and we will tell you once we finalize them. But both GPU and CPU clock speeds are not set and not final. Don't believe what you read on the internet, no. I know that some sites were saying, oh my god, it's going to be just as fast as the PS3, and oh wow, the ARM chip can be clocked up to 2 gigahertz, so obviously that's what they're going to do. Yeah, don't believe all that stuff. If we clock that thing at 2 gigahertz, like Dave said, it would probably burst into flames and melt a hole through your pocket, and the battery would last a few seconds. So we don't want that. Obviously, it's a battery-operated mobile device. It has very, very different engineering and design constraints than a console that can just plug into the wall and use power all the time. Battery life is important. Power drain is important. Heat dissipation is important. Physical die size is important. The chip can't be that big. It just wouldn't fit. It would take too much power. It would be ridiculous. So just assume that what you have now is what you're going to get. And if it goes up and if it gets faster, it's a bonus, and you'll get gain some frame rate on it. So just don't design for a 2 or 3 gigahertz target. That's not very realistic. So connectivity. We definitely want this to be extremely easy to use and have a lot of features at launch. Certain other mobile devices that have launched recently have been very crippled at launch, and half of the items in the system do not actually work, and it says it'll come in a future update, and there's no store, and there's just all these things missing. We're not going to do that. We know that everybody wants everything at launch, so the store is going to be there at launch. You're going to be able to download titles. We're going to have all the connectivity options there at launch, and then we're going to add new features above that as time goes on. And there's going to be some pretty cool stuff. John will talk about it later, some of the cool network stuff coming and some of the cool things that are happening on the network side. There's some really awesome location-aware applications and other things that we're doing, which should be really cool. And obviously the focus is on portable and social and network. And we'll talk about that later today. And there's a pretty little screenshot that you probably can't see much of because it's down-resed. Dev costs. We want to support, like I said earlier, we want to support a diverse range of titles, from your tiny little solitaire games all the way up to the huge Uncharted AAA productions that we'll see. I mean, you will definitely see a full range of titles. For the big games, you can actually reuse a lot of your existing assets from PS3 or other consoles. You're going to have to do a little bit of poly reduction. Some texture reduction is probably necessary because you don't have a 1080p screen here. You don't need 2K by 2K textures because you can't physically see it on the screen. So there's no reason to have all that. So you can usually drop your top MIP level and see no degradation in quality. Drop some polys, just again, because the screen is small. You don't want to go into wireframe and have a solid screen full of pixels. That just doesn't do anybody any good. And yes, we have seen that. Simplify your shaders. You do still have to write a platform-specific layer, but again, this is true with any cross-platform title. So the graphics layer is called GXM. It's very low level. It's very similar to GCM. So you guys who are writing PS3 code right now will be able to pick this up and get going really, really quickly. It is very easy. And again, you'll be able to use all your code on any NGP game. And you can take advantage of a lot of the really cool NGP user interface things that we have that other devices don't have. So quick summary, modern architecture like a PS3 or a PC. Performance is lower, obviously, so you're going to have to scale some assets, but it's still a surprisingly powerful little device. You can share your tools pipelines. A lot of the middleware guys that are working on their engines right now, their tools pipeline between PS3 and NGP are very similar, if not exactly the same. So your artist won't have to learn an entirely new tool set. There's not that much different. It should just be a pretty simple matter of saying, okay, screen is slightly smaller, polys are slightly less, and textures are slightly lower. Removable storage media, game card for the games, wireless connectivity for commerce, gameplay, social, networking, all that stuff is available at launch on day one. So it's going to be very cool. All right. Thank you very much for listening. Are there any overall questions before we get into the specific presentations about the features?